Alright, this is the solution to page 219, number 34. In this problem, part A asks for the before and after. We have a fullback, and I'm going to make that direction positive, moving one way. We have a defensive tackle, moving the other way. And when they collide, they cancel, so afterwards the P will be 0. Because at the end of the problem there will be no momentum, the beginning must have no momentum. Now they're obviously moving, so their momentums must be equal and opposite beforehand, and they cancel. Part B asks us to solve for the momentum of the fullback. That is simply 95 times 8.2, and the momentum, or P, is equal to 779 kilograms times meters per second. In part C, they ask, what is the change in the fullback's momentum? Well, if the fullback had positive 779 and ended up with no motion, no velocity, no momentum, then the impulse in part C that was required to stop that momentum would be a negative 779 Newton seconds. Part D. When they ask what is the change in the tackle's momentum, well, if the tackle had a canceling velocity and mass that equaled a negative 779 kilograms times meters per second, then the impulse that hit the defensive tackle would be a positive 779 Newton seconds. Remember, change in momentum has kilograms times meters per second. Impulse has Newton seconds. Part E says, what is the tackle's original momentum? Well, we said earlier that they were equal and opposite, so it was a negative 779 kilograms times meters per second. And finally, part F asks for the velocity. Well, we'll take the 779 from the earlier answer. We'll divide by the mass, 128 kilograms. We'll change the color so that we can show what's canceling, and that will give us an answer of 6.1 meters per second. Now, because the defensive tackle was moving to the left, and we called that the negative direction, his original velocity was also negative.